Okay, today we got Unit 4, Topic 6, Introduction to Titration. So, titration is an experimental technique used to perform a neutralization reaction in the context of acid and bases. You can use titrations in redox reactions and other types of reactions, but in this course we only look at the acid and the base titration. So, we need accurately graduated glassware, so like volumetric flasks or the burets that we use usually in titration because we have to be really accurate with our measurements. They are used in a quantitative manner, and we use it to determine the unknown concentration of an acid or a base. So you have this reaction mechanism set up where you're titrating the solution we don't know with something that we do know, essentially, and we'll look more in depth at this at the actual experimental technique when we get to acid base in Unit 8. But all we need to know for this unit is how to calculate the proportion to dilute a solution. So we are gonna look at this equation called the dilution equation. So it's M1V1 equals M2V2, and you'll notice that we use an uppercase M instead of a lowercase m, so it's not mass, and we don't use an N, so it's not moles. We use the uppercase M. We use the uppercase M for molarity or concentration. So we have the sample question. So let's look at how we do this. So how many milliliters of 3.0 molar H2SO4, so sulfuric acid, are needed to make 450 milliliters of 0.10 molar H2SO4? So you notice that they gave us three of our values. We'll call this value M1 up here, so the more concentrated solution, and this will be our M2, and this is our V2 because it corresponds with our diluted acid. So how we do this is we are just going to do our M1, which is 3.0 molar, and then our V1 is what we're solving for because we're looking for milliliters, which is a volume. Usually in this class we need to convert to liters, but with this equation it works out because both of our volumes are in milliliters, and usually with this dilution equation you can get away with using the same units as long as they match. So if they gave us both liters, we could use liters, but since they both give us milliliters, we can use that. So we're going to say this is, why does it always do that? Say this is X milliliters, and then that equals our M2, which is our 0.10 molar, and then we have 450 milliliters. So to get this by itself, this X milliliters, we have to get this by itself. So we can divide this whole side by 3 molar and divide this whole side by 3 molar. And so we put that on our calculator. We get 0.1 times 450 milliliters, which is 45. This is 45. And we divide that by 3, which I hope I don't need a calculator for. That is 15. Yep, so we get 15. And it asks us for milliliters, so that we know our answer is 15 milliliters of 3 molar H2SO4. And that is how you use the dilution equation for this unit, and this is topic 4.6.